Welcome to my new browser games playlist. For this playlist, I wanted to devote just to the game project since my previous playlist, it was about half and half. A whole lot of it was and basic stuff, which is fine, but I wanted to change things up with this new playlist, which is just going to be game projects. And I'm going to start that with the Tic Tac Toe game project that I mentioned at the end of the last playlist. I might add more to that other playlist, I might not. But what I'm going to do today is show you how to code tic-tac-toe. And again, I'm starting with very basic code here. My HTML document is right here. All I'm doing is linking the CSS, linking the code, and I have a canvas tag where it is set to be 500 by 500 pixels, which you can see right here on the screen. And the only thing I need with CSS is the border, a 2-pixel solid black line, so really I can just delete that. We're not going to change anything else with the CSS. You'll notice that even though I'm only going to be working from the HTML and the JavaScript files, I do have two other tabs. Bear with me, this is going to be a really long tutorial, and it's going to be probably the hardest one that I've done so far. Now, I still want to do it, and I still want to do it all in one take, but there's a lot of code here, and so I might refer to this other document where I have the completed code here. So I've practiced this tutorial a few times, but if I need to, I might switch over to this other file here to code that. But to start with, so we have the canvas. I'm going to go over to the code, and let's just grab the canvas. Did I give it an ID? No, I did not. So let's grab the canvas. Var canvas is equal to document.get element. Get elements by tag name canvas 0. And just remember that's what I do when I don't want to give an ID for a tag. I just want to grab it in the JavaScript like that. We get the whole list of the elements of this name, and we use the first one. And that's another thing. We're going to be talking a lot about lists today. Since my last video covered lists, we're going to be practicing that a lot more today. So now, time to create the context. Context is equal to canvas.get context 2D. And I'm going to go ahead and create a screen width variable. Var screen width is equal to canvas.width. I should really make that a const, since it's not going to change. So const screen width. And I'm making it short because we're going to type this variable so many times today that I want to make it as easy as possible. So just SWSH. So we have our canvas context, our screen dimensions. Now what we're going to do first is we're going to create the board data. I'm going to create a two-dimensional list, which is just a list of lists. Var grid is equal to, and this is going to be our tic-tac-toe board. It is going to be a list of 3 lists, and those 3 lists simply contain the tile data. So I'm going to initialize all the tiles with a space right now. Excuse me, not a space, a period. So here is our grid. This is a two-dimensional array. It is a list, but it has 3 lists on the inside. And really, I should space it out like this, because this is really the way we're going to be working with it. We're going to be working with it like this. If I put it out like this, you can kind of see much better how it's two-dimensional, where we have each list is one axis, one Y, and each item in the list is one X. So I have the grid there. Now what I'm going to go ahead and do is draw the board. Let's create a function to draw the board, since right now we have no graphics on the screen. So function draw board. And before I forget, I'm just going to call that function at the beginning of our program. So what are we going to do with the draw board? Well, first let's fill the background color with a color. So I'm just going to create a variable for that. Var bg color is equal to light gray. And now I'm going to fill the entire canvas with that light gray. Context.fill style is equal to bg color. Context.fill rect 0, 0, screen width, screen height, and all caps for those. And if I did all that correctly, okay, we have our background. Now, to make this a true tic-tac-toe game, we need to draw the tic-tac-toe grid. And so we'll do that next. And I have a picture to help us understand how we're gonna draw the grid. And it is this one here. This is our tic-tac-toe grid. Now we're not gonna draw these outer lines, that's just the canvas line that we already have on our screen here. We're really only drawing the inside. So I have this here, and let me move that. This is our canvas. The whole width of the canvas is screen width, which is, by the way, 500 pixels for us. The height of the canvas is also 500 pixels. And remember, JavaScript starts the position 0, 0 in the top left corner. So this is 0, 0. This corner is 500, 0. This bottom left corner is 0, 500, and this is 500, 500. So I want to draw this grid here. I'm going to start with this line. How do we draw a line from this point all the way to the bottom? Well, this point here, if we think about it, the x is simply screen width divided by 3, and the y is 0. So let me write that down. That's just screen width divided by 3, 0. Now down here, what is this point? Well, that point is simply screen width divided by 3, screen height. Very simple. That's our vertical line. The second vertical line is simply the x is 2/3 of the screen, so screen width times 2/3, and the y is still 0. Down here, this position by my mouse is screen width times 2/3 still, but this time the height is screen height. So if we can map out the positions of the start and end positions of the lines, we can draw the lines. So in our code, let's draw the vertical lines. Vertical lines, and let's also set a line color. So I'm just gonna set this. I'm gonna create another variable var line color, or I'll call it grid color, and it's just gonna be black. Let's also set a line thickness. Color. Var grid width is equal to 5. So with that, we already know how to draw lines in Canvas, so that will be easy. Stroke style is equal to grid color. So we're going to set the draw color to black. Context.line width is equal to grid width, so our lines are going to be 5 pixels. And now we can start drawing the line. In fact, I should move this comment here. That's just a setup. Now we're going to draw the line. So for a new line, we need to begin the path, context.begin path. Now context.move to, and I'm going to start with this first line, which is going to be screen width divided by 3, 0. So screen width divided by 3, 0. We're going to move in the top, context.line to screen width divided by 3, screen height. And then finally, we create the line with the stroke function. Now, making sure I did everything correctly, I'm going to refresh, and we get one line down the middle. I'm also going to make sure I'm still recording, and yes, I am. Great. So we have that there. Now let's draw the next line. So context.begin path, context.move to, and this time is going to be screen width times 2/3, 0, context.line to, screen width times 2/3, screen height, context.stroke, and that should give us our second line. So now let's do the horizontal lines. And again, once you get the first concept, the rest of this is easy. So where is this position here? Well, this position is simply going to be the x is 0, but the y is screen height divided by 3. And this far left position is screen width, screen height divided by 3. This point is going to still be 0, and then screen height times screen height times 2/3, because this is 1/3, this is 2/3. So 0 for the X, screen height times 2/3. And then this position over here is going to be screen width and then 2/3 of the screen height. So it's pretty straightforward with the grid. Let's draw the horizontal lines. Horizontal lines, context.begin path, context.move to 0, screen height divided by 3, context.line to screen width, screen height divided by 3, context.stroke. Now let's just do the other line. I'm going to begin the path, context.begin path, context.move to screen, excuse me, this is 0. I keep messing that up. We're going to start at 0, screen height times 2/3, context.move line 2, and we're going to do that final position, screen width, screen height times 2/3. Context.stroke. And if we did that all correctly, I almost said with a stroke of luck, but that would be a bad pun, and I hate puns. So there, now we have our full grid here. We have all the lines ready to go here. Now, here's where the tutorial is going to get tricky, but this is actually, I promise you, this is the hardest part. We need to make it to where the draw board function, the next part is drawing any of the moves. Like here's our board, our 2D list. And I'm going to put an X in the middle, and I'm going to put an O in the corner. We need to make it to where we can use a for loop to run through this grid, and if we detect an X or an O instead of a dot, we're going to draw an X or an O in that spot. So what I'm going to do is I'm going to, well actually first I have another picture to explain really what we're doing. So here is our grid, our list of lists. This first list here that I've just circled, that list is grid 0. It is the first item of our list. The second list is grid 1. This third list is grid 2. But these lists have items in them. So this first space is grid 0, 0. The 0th item of the 0th item of grid. And then you can see the pattern. This second space is the first item of the 0th item of the list, and then so on. Or let's skip over to this one. This is grid 2, the second item or second index of our grid. So this middle one here is grid 2, 1, because it is the first index of our second index of the grid. So if you need to pause the video, take a look at this chart, you can go ahead and do that. But this is to visualize how we're going to process our grid. This dot here is going to be grid 1, 0. Why 1 here? Well, it's because it's our second item in the list, but our first item in our second list there. So if you need to take a look at that, you can do that. And here's how we're going to actually process each item of the list. We're going to use a for loop inside of a for loop. I'm going to type for, let y be 0. Y is less than 3, y plus plus. And now I'm going to put a for loop inside of this. For let x be 0, x is less than 3, x plus plus. Now I have an X and a Y. What is the current tile as I'm going through this for loop? The current tile, let tile, is simply grid Y, X. And I have another picture to explain that. Here's our grid here. And again, this is why I moved the grid like this in our code so we can more easily see how the data is being packed. So this top row is the first list. This middle row is the second list. This bottom row is the third list. So you can think of these rows as the y-axis. This is grid 0. This is grid 1. This is grid 2. Let me draw that over to the side here. This one is grid 0. this is grid 1, this is grid 2. These rows are the 3 lists inside of our grid. But now the columns are the items inside of that list. So you can think of this one. This is going to be grid 0 and then 0. It is the first item on the 0th index for the y. This is going to be grid 0, 1, grid 0, 2. That's how this system's going to work. And when you pack the grid like this, when you draw it like this, you can kind of see this is why this is called a two-dimensional array or a two-dimensional list, because one dimension is the lists themselves, the y, but then the other dimension, the x, is the items within that list. So that's how we're packing this data. And if we look at the for loop, again, this is probably going to be the hardest part of the tutorial, but it gets easier after that. If we look at the for loop, this first for loop is going through the y levels. It's going to say, okay, let's first go through this, then let's go through this, then let's go through this. That's what the first one is. Let y be 0, y is less than 3, y plus plus. The second for loop is going through each individual items of the list of the list that we're currently looking at. So we're looking at 3 lists at a time, but the extra for loop, the for x for loop, is looking at each item in each list that we're looking at. So that's how I can say here, tile is simply grid y x. We have the current tile. So I'm going to keep going now. If the tile is an x, we need to draw an x in this position. How do we draw an x in this position? Well, I have another picture for that. Actually, I don't have a specific picture for that, but let's just look at the example. And by the way, where did I put the x? I put the x in the middle. Good. Okay, that'll make it easier to see. So we're going through each individual tile, and we detected an x. So we need to draw an x at this position. So let's say we're in this middle spot here, and there's an x. How do we draw an x here? Well, we need to know where all we need to do is draw a line from this spot to this spot, and then this spot to this spot. But the thing is, we need to know where these coordinates are. And so, what this spot is, this is currently simply the width of the tile. Let's go ahead and create a tile width variable. And this is also going to be constant since this does not change. Const tile width is equal to screen width divided by 3. This is going to just be how wide the tile is, how wide it is. But since our tiles are squares, tile height is going to be the same. And so I could have said tile width is tile height divided by 3. That would have worked the same way. We're working with squares, but either way, the width of each individual box on our grid is just our screen width divided by 3. So what is this corner position here? Well, that's going to be our tile width multiplied by our x position. At least that's the x. So if we're on this spot here, well then our y is currently 1, our x is currently 1. So what is this position here? That's going to be tile width times x, which is just going to be tile width. So what I'm going to do is I'm going to go back here. I'll scroll down. So we're going to say context dot, and let's go ahead and set a color. Let's set an x color. Var x color is equal to blue. Var x width, that's just going to be how thick we're going to draw the x's, and I'm going to set it to like 10. So now context dot stroke style is equal to x color. Context dot line width is equal to x width. Now we need to begin the path, context dot begin path, and we need to move the context right here. So again, this position is going to simply be the tile width times x, and by the way, the y is just going to be tile width times y, like that. So now we know where to move the context. Let's move the context there. Context.move to x times tile width, y times tile width. So we're going to draw it here. Now, what is this position? Well, this is actually really easy. This is simply the tile width times, and let's see if I can make this font smaller. It doesn't look like I can. I'll just do it right here. This corner position is our tile width times x plus the tile width. That's the x. And then the y is going to be the tile width times y plus the tile width. That's actually pretty easy. So again, all together, this corner position here, and I hope this isn't confusing you. You can pause, you can rewatch this, take a picture of what I have here. This corner position right here by my mouse is going to be the tile width times x, tile width times y. This position is going to be tile width times x plus an extra tile width, and then tile width times y plus an extra tile width. Because all we did is we slid over one tile width and down one tile width. So with that, let's go ahead and add the line. Context dot line to x times tile width plus tile width, x times, y times tile width plus an extra tile width. Context.stroke. So now I've added the grid. This middle is x. I've added that. Let's just refresh the page and see if that works. And we get the line from this top corner to this bottom corner here. But also, I'm just going to shorten this. X times tile width plus tile width is just the same as x times tile width times 2, I believe. I'm going to change these to times 2. Yeah, and it works the exact same way. Okay, so now what about that extra line here? Okay, for that extra line, where is it? Okay, right here. So this position, what is this position? That's going to be, that position is going to be tile width times x times 2, and the y is going to just be tile width times y. Now this bottom position here is going to be tile width times x, tile width times y times 2. So let's add those positions here. Let's create the next line. Context.begin path. Context.move to. Where are we moving to? X times tile width times 2. Y times tile width. Then we're going to draw the line to x times tile width, y times tile width times 2. Context.stroke. Time to refresh the page. And sure enough, we get the full x in that spot. Let's just make sure that this is working. Again, the reason this code is so hard is because we're trying to account for any possible position of the x. That's why we're doing this multiplying by x and multiplying by y here. So to make sure we did this right, I should be able to replace this x with a dot and move an x in a different spot, and it should move. Oh, and I made a mistake here. So when I move the x from here to here, for some reason it doesn't draw correctly anymore. I'm going to refresh it. Let's see what I did wrong here. Begin path, stroke, begin path, move to. All right, so move to. I actually have no clue what went wrong here, because do I have any other x? No, I don't. Tile width, x times tile width, y times tile width. I'm just going to pause this and figure out. All right, I figured it out. You cannot multiply by 2. I messed up the operation there, and I should have caught that earlier. But for our purposes, we have to simply add an extra tile width. And then when you do that, you should be able to move the x wherever you want. I'm going to move the x here and move another one here, and it should draw 3 different x's there. So we're good with that. Again, that was a lot. If you need to rewatch the video, go for it, because I know that was a lot of explanation. It's just about understanding what's the point of adding the tile widths and things like that. But I'll move on. Now let's worry about drawing the circle. So again, this double for loop lets us go through the two-dimensional list, and we've detected if a tile is an X, and we can draw an X. But we need to see if we can draw an O as well. So I'm going to add an else if tile is O. And how do we draw a circle? Well, the circle is actually a bit easier. All we need to do, and we've already done circle drawing inside of our um, tutorial series. Just remember to draw a circle. You just say context.arc. You know, your x, your y, your radius, 0, math times pi, math.pi times 2, and then context.stroke. That's how you draw a circle, but we need to know, where do we start the circle? What's the middle point of that circle, and how big should it be? So for that, we're going to go back to our picture, and I have a whole lot of stuff here, so I'm going to go ahead and delete some of this. Drawing the X's is a lot harder than drawing the circles, but here's how you draw the circle. I'm going to get rid of that. So to draw the circle, let's pretend that the circle is right here in this grid. What we need to do is get to this middle position here of a tile. So how do we get to the middle position of a tile? Well, for that, all we're going to do is go to the corner and then add half the dimensions of the tile. So this corner here, what is that corner? Well, that's going to be x times tile width, y times tile width. But now that gives us the corner. How do we go from there to the middle? Well, the middle is just going to be x times tile width plus tile width divided by 2. Because you can actually see this. All we're going to do is we're going to take the same corner position. We're going to add half of the width of the tile for the x and half of the width of the tile for the y. And that will give us the middle. So let's do that. So let's go ahead and also set an O color. Var O color is equal to red. Var O width is equal to 10. That's just going to be how wide the line is for the circle. And for the O size, I don't need a variable for that. We'll cover that in a second. So context.stroke style is equal to O color. We need to reset the color. Context.line width is going to be O width. And then now let's draw the circle. Context.arc. The x position is x times tile width plus tile width divided by 2. So again, just this corner position plus a half. Y times tile width plus tile width divided by 2. The radius, I always found it best to just do the width of the tile divided by 3. For the, and then the last two we already have, 0 and math.pi times 2. Context.stroke. And with that, do we have an O in our grid? We have one right here. So we should get an X here, 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 and an O down here. So let's refresh. Okay, so we get an O, but the thing is, it tried to draw the O starting from the last X, and it drew it all the way here. And it kind of dragged the pen there. We don't want that. So that tells me I forgot to add begin path. I believe I forgot to add begin path. And sure enough, I set the new color and line width, but I don't begin a new path. Context.begin path. And now we get that working correctly. So let's just make sure this is working and our math is all right. I'm going to move the O here, O here, O here, and we should get that exact grid. Perfect. So now we're able to draw our board based off of whatever the data is in the grid. And good job for getting through this part. This was definitely the hardest part of the tutorial, but the rest of it is easier, definitely easier than this. So all we're doing, this is drawing the grid for the Tic Tac Toe board, and now we are drawing the the individual X's and O's. So now let's worry about the player move. So we have the perfect drawboard functionality, but we need to be able to enter a player move. So for that, I'm going to go to our HTML and create a form and let the player enter the X and Y position of the tile they want. So form, I'm going to create a form here. And this is I have a video that covers all this stuff before, so you can review my forms video, but I'm just going to create two text boxes. Input type is equal to text, and I'm going to say, value equals X. The value is simply oh no, I'll do the labels for that. Ignore value. So I'm going to create a text box, and its ID is going to be X input. And we get a text box right there. But let's give a label for that text box. And again, I have a video that covers all this stuff. Label 4 is equal to X input, same ID as what we had here before. X position / label. And we get our label and our text box. And I don't really like XPOS, so I'm just going to make it X. So now let's do the same for Y. Label 4 is equal to Y input, Y / label input ID is equal to Y input, type is text. So we have two text boxes that will let us add an X and a Y position for where we want to go. So now let's add a submit button. Input type is equal to submit, value is equal to enter. And this value is the word that appears on the box here. So we have our X input box, our Y input box, and an enter button to submit our answer. Now let's go over to the JavaScript and code that. So let's grab the X and Y buttons. Var X input is equal to document.getElementById X input. We're going to need this in a second. Var Y input is document.getElementById Y input. And then the submit button, which needs an ID. I'm going to give it ID equals submit button. So now I can say submit is equal button is equal to document.getElementById, and then it's actually what I should be doing instead is getting the form and then using the, I'm sorry, ignore that. So I don't think we need to grab the ID. I don't think we need to grab the submit button. We need to grab the form though. So form ID is equal to form. That's my bad. We need to grab the form instead. So form is equal to document.getElementById form. And now, so we grab the X input, Y input, and the form. The button is just for us to signal when the form has been submitted. That's all that does. So here's what we need to do. We need to create an event listener for our form. Form.add event listener. Submit is the event we're waiting for. Again, that's why we added that button. And here's what we're going to do when we submit. And I'm adding a parameter E, which, if you recall, stands for event. Here's what I need to do. When we submit, when we click the submit button, what we need to do is run a function called player move, and we need to also prevent the page from refreshing. So let's create that player move function first. Function player move. And all I'm going to do is console.log x input.value, console.log y input.value, just to make sure our form is working correctly. But remember, this wouldn't work by itself, because if I run this and I put 1 and then 2 and I try to click enter, we get 1 and 2 in the console, but then it immediately refreshes. So to prevent the refreshing, which this was in my number guessing game, you just say e.prevent default, and that will keep from this event, the submit event, from refreshing the page, which is really useful. So we're going to prevent the page from refreshing, and then we're going to call the player move, which is simply going to log x and y. So now let's run that again. 1, 22, and we get our x and our y saved right there. So now let's actually process the player move. We know exactly where the player wants to go. Now we just need to determine if he can move there, and if he can, we're going to replace the grid with an x, since I'm going to make the player the x. So let's go ahead and grab the x and the y values. Let x be x input dot value, and just to be on the safe side, I'm going to convert this to a number, because it might be a string already, I don't remember. And I'm also going to subtract 1. And I'm going to do the same for y, and then I'll explain why we're subtracting 1. Number y input dot value minus 1. So the reason I'm subtracting 1 is because as a human, like, it would make sense for this position for the x to be 2, 1, 2, 3, and this position for the y to be 2, 1, 2. But the thing is, remember, JavaScript counts from 0, so even though this spot on our grid is actually the position 1, 1, not 2, 2. But I don't really want the player to have to worry about that. I want the player to be able to look at this tile and just say 3, 3, and the computer knows what it's talking about. Even though for the grid, this is really just 0, 1, 2. So grid 2, and then 0, 1, 2. Grid 2, 2. So we're just going to subtract 1 so that the player can use, reasonable numbers, but we convert it to account for JavaScript counting from 0 for our lists. Let's do some checking. If x input, actually we should do this first. Let's make sure that it's empty or not empty. If x input dot value is blank, or y input dot value is blank, then when we need to alert to the player that they're missing data. So let's go over, and I could just, alert, try again, but I really don't like the alert function. It's really obnoxious. So instead, we're just going to create a paragraph tag at the bottom. P ID equals feedback /p. And what we're going to do is we're going to set the inner HTML to have a message in case they do something wrong. So in this case, let's grab that paragraph tag. Var feedback is equal to document.get element by ID feedback. And I can say that if they did not enter in an X or a Y value, then I'll say feedback.style.color is red to get their attention. Feedback.inner HTML equals missing data. Let's make sure that works. I'm going to refresh the page. I'm going to put in a 1 and a 1, and we shouldn't get anything. But now I'm going to delete these and have nothing. Missing data. And I don't know why I capitalized data only. Data. There, so we now have an angry message for when they're missing data. Now, let's also make sure that they're entering a value or a tile that is in the right range. So if x, so we're going to be dealing with the numbers we calculated now, if x is less than 0, or x is greater than 2, or y is less than 0, or y is greater than 2, we know that they typed something outside of the range, because if you look at the picture I had earlier, these are all the ranges for our grid. Our maximum y is 2. Our maximum x is 2. So they cannot put in anything below 0 or above 2. Or in their case, below 1 and above 3 since we're subtracting. But you get the point. So if any of these happened, they were outside the range. So let's tell them feedback.style.color is red. Feedback.innerHTML is invalid range. Now let's make sure that that tile isn't grabbed. So let the tile be grid y x. If the tile is not equal to a dot, that means it's already been taken. So, and I'm going to copy and paste this for a little bit more speed. Paste, feedback, red, okay, valid range, spot already taken. And we should do a few more things first. We should not just add the feedback, we should also exit the function so that they get to try again. So I'm going to exit the function here. But if they get all the way to this point and the function has not exited, that means that this is a valid tile. And so we can say grid y x is equal to an x. And right here, this is where we successfully registered these player move. But we need to do something else. The player move needs to also signal to the computer that it's his turn to move. So what we need to do is redraw the board. And then we need to signal for the computer that it's its turn. But first, let's just make sure this works. And I'm also going to, well, actually, I can leave this. I'm going to refresh. I'm going to put 2, 2. And it says invalid range. Why does it say invalid range? I must have done something wrong here. Because 2, 2 should be this middle spot here. If x is less than 0 or x is greater than 2, y is less than 0 or y is greater... this should be a 2. I made a mistake there. So we're making sure that x cannot be a negative number, y cannot be negative, and we're making sure that x cannot be greater than 2 and y can't be greater than 2. Let's try that again. So I'm going to put 2, 2. That gives us a middle. Now let's do 3, 3. And now if we did 3, 3 again, spot already taken. 1, 3, spot already taken. If I do 132, invalid range. If I do negative 932, invalid range. Perfect. So this function's working. Now let's get the computer's move. I'm going to stop, make sure I am still recording. Okay, great. So function computer move. And again, once we draw the board, we're going to get the computer move right there. The computer move is really easy. All we're going to do is we're going to use a while loop. And what we're going to do is generate a random x and y. And then if that spot is not taken, then we're going to use that spot for the computer. And I know as far as AI goes, it's really lame. The computer's just going to be picking a random spot. But imagine how crazy long this tutorial would be if I actually did a good AI for now. So this is all we're going to do, the random move selection. So let rand x be math.floor math.random times 3. That will give us a random value of 0 to 2. Let rand y be math.floor math.random times 3. And now, let's grab the tile. Let tile be grid rand x, y comes first, rand y, rand x. And what we're going to do is if this tile is an empty spot, we're going to set the computer to, we're going to take that spot for the computer, and then we're going to use the break keyword so that we can exit this while loop. So if tile is equal to a space or a period, then grid rand y rand x is going to be equal to O. and then break. Because again, you guys might have been confused why I started out with an infinite loop while true, but this will break right here. If we choose a random X or Y that gives us an empty tile, then we can break. And so once the computer has successfully chosen their spot, we're going to draw the board again. And now that should be most of the game mechanics minus minus checking for the victory, which is the last thing we're going to do. So you guys have probably been dying for me to do this for a while, but I'm finally going to clear the grid and we're going to test this out. So I'm going to refresh and we have a blank slate. I'm going to choose 2, 2 to start with. So I choose 2, 2 and the computer chose the top spot. I'm going to choose 1, 2. The computer goes there, and I'm just going to go ahead and win. I'm going to make that 3, 2. And yep, and I won. But of course, nothing actually happened because we haven't coded the victory checking yet. I'm going to do 1, 1, and we're just going to fill up the entire spot here. 1, 3. Oh, excuse me, that would be 3, 1. 1, 2, 3, 1. It says spot already taken. Why does it say? Oh, yeah. This is the problem because now the game's frozen because I use this spot here, but now the computer is unable to generate a move because every spot is taken, so now this loop is running forever. But we'll actually fix that later. I'm not worried about that now. So now we have that working. Let's focus on checking for victories now. Because let me just review the order. The order is this. The game starts by submitting the form. So we go to the player move function. We check, make sure the form is filled out and all correct. And once we enter in the player move, we go to the computer move. Then the computer move runs, then we draw the board. So now with that all working, let's go ahead and code up the part where we check for a victory. So I'm going to make a check for victory function. Function check for victory. And now what we're going to do here, this is a really easy function to write. It's just long. What we're going to do is check for horizontal wins, vertical wins, and the 2 diagonal wins. So this is going to be 8 different wins. So what I'm going to do is I'm going to make sure, I'll start with horizontal. I want to see if this is the same as this, and if this is the same as this. So let's add that. I'm going to create a winner variable. Winner is going to be a dot. And what we're going to do is we're going to change this dot to an X or an O, depending on who gets the 3 in a row later on. More rhyming in my coding tutorials that I don't like. If grid 0, 0 is the same as grid 0, 1, and that spot, grid 0, 1, is the same as grid 0, 2. That is the horizontal check that I just did. That is this spot right here. I just checked to see if this is the same as this, which is the same as this. So with that, I can now say winner is equal to whoever got that. Whoever started that 3 in a row is the winner. And that's just how we're going to check who won. We're going to start the winner as a dot, but then we're going to set the winner to whoever got one of the 3s in a row. And then we're going to see if that's an X, we say that the player won. If it's an O, we say they lost. Else, and I'm going to check for the row below that. I'm also going to copy and paste this so it's faster. If the grid 1, 0 is the same as 1, 1, and 1, 1 is the same as 1, 2, then winner is going to be grid 1, 0. So I just checked this row. If this is the same as this and this is the same as this, then the winner is whoever did this. That is all I'm really doing here. Let's do the same. Oh, this should be else if. Now I'm going to do the same for the next one. If, else if. Grid 2, 0 is the same as grid 2, 1, and grid 2, 1 is the same as grid 2, 2. Then that is our last horizontal win. Winner is equal to grid 2, 0. Now the vertical wins are not harder at all. We're just going to, instead of constantly changing the X number, we're going to be changing the Y number. So else, if, I'm going to start with this. I'm going to check this one, and then this one. So else if grid 0, 0 is the same as grid 1, 0. So the same X level, we're still using 0, but I just went down 1, grid 1, 0. And grid 1, 0 is the same as grid 2, 0. If that happens, then our winner is whoever did grid 0, 0. Else if, and I'm going to copy this, make it faster. In fact, I can copy this whole structure here. I'm going to change this to, I'm going to change all the X's to 1s instead of 0, so that we're now checking these instead. I'm going to change this to a 1. And now I'm going to do the last, for that last vertical win, I'm going to change all the X's to 2s, which will give us this row here. So now I've checked for the horizontal wins. I'm going to make a note, horizontal wins. Now, then these were the vertical wins. Notice I'm not using curly brackets here because when you only have one statement to run for an if statement, you don't need curly brackets. And I'm doing that to make this code a lot shorter. Now the diagonal wins are going to be, I guess, a little harder, but it's still really easy. Diagonal wins. I just need to see if grid 0, 0 is the same as grid 1, 1, and if grid 1, 1 is the same as grid 2, 2. So if grid 0, 0 is the same as grid 1, 1, and grid 1, 1 is the same as grid 2, 2, then the winner is grid 0, 0. Now for the last one, we need to check if this is the same as this is the same as this. So that's going to be checking if grid 0, 2 is the same as grid 1, 1, and 1, 1 is the same as 2, 0. So I'm going to paste this. If grid 0, 2 is the same as 1, 1, 1, 1 is the same as 2, 0, then the winner is 0, 2. And that is our check for victory function, except, oh, I said victor. That's kind of cool, but I like victory more. That's up to you. So now what we're going to say is if the winner is an X, we know the player won. So feedback dot style dot color is green. We're going to make our feedback text green. Feedback dot style, dot inner HTML is you win exclamation point. Else, if the winner was an O, then you lost because the computer is playing the O. So let's add that. I'm going to copy and paste this to speed it up since this tutorial has been running for a while. We're going to do, let's just do purple, I guess, when you lose, because I want to be red. I want red to be reserved for when you enter in incorrect values. So, and with that, I actually want to put the page back. Oh man, the page is still refreshing from the... There we go. I'm going to close that tab. There. Okay. But like I was saying, I want red to be reserved for when you make an error. So it's going to say purple. It's going to be purple, and it's going to say you lose if the winner was determined to be an O. Now with that, we need to make sure we check for a victory after every move. So after the player moves, we need to check for a victory. Check for victory. Draw the board. And inside the computer move function, we're also going to check for victory. Like that. Now, the only thing we need to do is make sure that the computer does not try to keep picking moves after you've won. So like if I, as the player, choose to make the winning move, we check for a victory, And then we draw the board, but the computer move, like we saw a second ago, the computer move is then going to, it's going to try to generate a random tile that's not taken, but since either all the tiles will be taken, which is very possible, we're going to get this infinite loop. So what we're going to do is I'm also going to create a play variable. Var play is true, but as soon as the check for victory finds a winner, we're going to set play to false. Play is equal to false. And play is equal to false. Now, what good does that do? Well, now with a variable, we can see we can stop the computer from choosing a move if play is false. So if play is false, return. And the computer will never even try to pick a move if play is false. By the way, a shortcut for this, you can just say not play. Let's do the same for the player move. We should not be allowed to continue entering values if the game is over. So I'm going to say if not play, return. And with that, that should be actually most of the Tic Tac Toe game. I'm going to refresh. I'm going to enter 1, 1. Now I'm going to enter 2, 2. And I'm going to enter 3, 3. And it says that I win. But will it let me run again? Well, can I try doing the move 3, 1? And no, the enter button does nothing because now the game is over. Very good. Let's try this again. I'm going to go for 1, 1. I'm going to go 1, 2. And I'm going to go for 1, 3. And I win. And sure enough, you notice the computer doesn't take another turn. Let's check one more time to make sure I haven't missed anything. I'm going to start here. 3, 3. And actually, let's let the computer win this one. I'm just going to play this really dumb. So I'm going to do this move. Okay, so the computer just needs to pick that one. So I'm going to go here. X3, Y1. The computer is really dumb. This is what happens when you only hear going for random moves. And the computer, man, the computer just didn't do it. Let's try to do that again. I really want you guys to see the computer losing, or the computer winning. And I'm going to take the middle spot since the middle spot's really bad most of the time. Okay, I want to see if this will check if the computer is winning. I'm going to choose X of 3, Y of 2. Okay, you just need, there's no way, yeah, he has a guaranteed victory now. So X3, Y3. And it says you lose because it detected the 3 in a row. And I wanted to stress test that a little bit just to make sure I didn't miss any of the move possibilities here. So let me summarize. We're almost done with this video. Let me summarize the way this works because I know the structure is a bit weird, but again, the game starts with the submit event, which happens when you click this button. So we go to player move and we set the player move here. We check for a victory, we draw the board, we go to computer move. Computer move will do his move, check for a victory, draw the board. And then at that point, the game pauses until we get another player submit event, in which we do that again. Player move, victory, draw board, computer move. And then we just keep repeating that process until all the tiles are taken. And let's make sure that I cannot enter this spot here. So I'm going to enter 2, 1, and we cannot keep going. So with that, there's only one thing I want to do now, and that is I want to code it to where the computer can start the game. So with that, because notice the way this works is the game does not start until you choose a move. So let's add a button that will start with the computer move in case we want the computer to go first. And this is going to be really easy. You've already gotten through all the hard stuff. So I'm just going to add a button here. Button. And I don't think I've ever showed you guys the button tag. I might have. I typically don't use it because it's the exact same as like a submit, an input tag here. And I've almost never need it. But here I'm going to use button. I'm going to set its ID to computer first. Or no, computer start. And I'm going to set the text to click here to have the computer start /button. And I refresh that. Now it puts the button here. That's because the canvas ends here. So let's just add some space. I'm going to add a break before that and a break after that. And not looking good enough for me. I'm going to add one more break. There we go. So the button's here and our text is right here, and that's looking good. So now let's code that button. I'm going to go here. Let's grab the button. Var computer start is equal to document.getElement by ID comp start. And let's add the event listener for that button. So I'm going to close you, close you. All right, computer start dot add event listener click, and this is what we're going to do when we detect the event. We're just going to run computer move. Now the only problem with this is pretty good, but the only problem with this is it lets me do nothing but computer moves. And sure enough, I just lose. Oh, but interestingly enough, if I try to run the button again after you lose, it doesn't work, so that works. But the only problem is you can enter this as many times as you want. So if you want to leave it as that, that's fine, but I'm going to go ahead and add a flag here. I'm going to add a var game started, and I'm going to start it as false. But when that button is clicked, I'm going to set it to true. So I'm going to say if game started is false, then and only then will we do the computer move. But then I'm going to set game started to true. Let's see that again. So the very first time this button will work because game started starts as false. So we're going to do the computer move, but then the variable is true and we're never going to get to use this button again. So let's try that. Oh, and I made a mistake because now I can't do it at all. So let's see. If game started is false, computer move game started is true. Game started is false. Oh, because I did game started. It should be game started. So I can do the button once, but I can't do it again. Now there's just one other thing I have to take into account. What I can do is I can type in a move and then do an extra move for the computer. Let me show you that again. I can type in my move and then the computer will pick one. And even though the game has started, I can still use the button. So let's make sure that the game started also turns to true after the player does their move here. So what I'm going to do is at the end of the player move, let's just make sure game started is true. So I'm going to click here and I can only click once. Now let's start the game with the player and now I can't click the button. And if you have finally reached the end of the Tic Tac Toe tutorial video, definitely the hardest tutorial I've done. So if you've watched all the way to the end, which I hope you all do, but I get it. There are some YouTube tutorials like on Blender that I don't finish. But if you've gotten through all this stuff, excellent work. This has been my hardest tutorial by far. You will probably need to rewatch parts of it over and over again, but that's fine. That's all part of the process. Thank you for watching.